welcome to Mrs. Lobuski's Math Blog. Today we're working on Module 2, Lesson 3, on interpreting and computing division of a fraction by a fraction. On Monday we looked at a fraction divided by a whole number. Yesterday we did a whole number divided by a fraction. Today we're going to do fraction by a fraction, okay? So we start by looking at a model to represent 12 divided by 3. So our whole is 12. So if our whole is 12, and we're dividing it by 3, so we have 12, 3 groups, each one is 4. Or we could model it this way. If our whole is 12 and we want groups of 3. Either way, 12, how many even groups of 3 can we get out of 12? Everybody? 4. Exactly. So we're looking to form even groups. Either way, we have even groups, 3 even groups, or groups of 3. We were actually told that it could be done either way. Those both represent the same amount.
For the first one, could you, instead of writing 4 in the boxes, could you do like
4, 8, 12? Yeah. So let's keep that in mind. And how could we word that? Well, we could say we divided 12 into 3 groups of equal size. So what's the size of each group? Or if we divide 12 into groups of size 3, how many groups would we have? So those are different ways. You just have to copy down the first 2. The last 2 are just examples of how you could word it. If I have 12 chickens and I put 3 chickens in each cage, how many cages will I need? And if I have 12 flowers and I place 3 flowers in each vase, how many vases will I need? Okay? Oh, move up then. There's seats up here. You can come up here. You don't ever have to ask. If you can't see and you see an empty seat, grab it. And if it's not empty, just tumble them out of the way. All right. Okay, let's continue. Draw a model to show the division problem 8/9 divided by 2/9. So let's think about how we can rewrite that. What does that mean? So I want to find out how many two-ninths are in 8/9, because that's what we did in our example. We found how many groups of 3 are in 12. So we're going to see how many 2/9 are in 8/9. So what's my whole? What do I have that I'm dividing up? 8/9. So let's draw 8/9. So we have 8/9. So what I want to do, though, is find how many groups of 2/9. So here is a group of 2/9. Here's a group of 2/9. And I did something wrong. Okay, let's get back on track now. Here is a group of 2/9, and here is a group of 2/9. Does everybody see what I did? I took my 8/9 and I pulled out groups of 2/9. So how many groups are there? 4. So there are 4 groups of 2/9 in my 8/9. So 8/9 divided by 2/9 equals 4, because I made 4 whole groups. So one way to interpret the question, like we said, is how many 2/9 are in 8/9? From the model I can see, and this is what I would like you to write, what I've highlighted in blue. There are 4 groups of 2/9 in 8/9. Now wait a second. Take a look at that equation and the answer. Can anybody make some sort of conclusion, some statement, a claim?
Just 8 divided by 2.
Look at that. 8 divided by 2 is 4. We get the same answer, and that works because we have common denominators. Exactly.
Is that going to work in every problem?
When there's common denominator, let's find out. So we've made a claim that when you have common denominators, you can just divide your numerators. Let's see if that claim is supported by doing more practice. Sound good? Okay. Let's continue. So 9/12 divided by 3/12. So what should our answer be based on that claim? Just by dividing our numerators. What should the answer be? Everybody? Let's just keep that in the back of our mind. We know we have to draw a model and we have to write it as a sentence. So let's see, what are we looking for? How many 3/12 are in 9/12? That's what we're trying to figure out. So let's look at 9/12. So I made my 12 boxes, and I'm going to count them again just to make sure I didn't make a mistake. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I have my 9/12. I'm looking for groups of 3/12. So here is a group of 3/12. Here is a group of 3/12. Here is a group of 3/12. So, what do we get? 3, just like we had thought. So I was able to take my 9 units, divide them by 3 units, and get 3 groups.
So you're only able to circle the ones that are shaded in? Like
Of the ones that are shaded in, because we're only looking at 9/12. Okay, so the shaded in represents my 9/12, because that's what we were given. Let's look at another one.
Can you please go back to the first one again?
Sure, we'll do that at the end. We'll go back to that, okay? 7/9 divided by 3/9. So we want to know how many equal groups. So how many 3/9 are in 7/9? Well, let's draw our 7/9. Okay, 7/9. One, 2, 3, 4, 5, 6, 7, 8, 9. Okay, double check to make sure I don't make that mistake again. So I'm looking for groups of 3/9. So here's a group of 3. Here's a group of 3. Alrighty. How many groups of 3 did I make?
2.
I made 2 whole groups. What does this represent? What's left over? Nice. 1 of my 3 boxes are shaded in that are left over. So 7/9 divided by 3/9 equals 2 1/3. Let's see if that works, because remember we said if we divide our numerators, we're supporting that claim. So we're saying 7 divided by 3 should be 2 1/2. Well, 3 goes into 7 twice, 6, and 1. I remember from elementary school when I'm dividing, the quotient becomes my whole number, my remainder becomes my numerator, and my divisor is my denominator. So did that work?
Yeah.
Yes, that worked. Okay. Ready to try another one?
Yeah. How'd you get 1/3?
Because do you see everything that's shaded in? This shaded in area, how could I represent that? That's 1 out of 3. Okay, so that's 1/3. Good question. All right, now we're going to look at how we could set them up a little bit differently. Instead of doing tape diagrams, we could also use number lines. Both methods are acceptable. It's up to you which one you would prefer. So, in the following exercise, rewrite the division problem, then be sure to draw a model to support your answer. So, how many fourths are in 3/4? So, to write that as a division problem, we have 3/4 as our whole, and we want to know how many 1/4 are there. So, we're dividing it by 1/4. So on my number line, I counted up my number line by fourths, 1/4, 2/4, 3/4. I can continue my number line as far as I want, because number lines go on forever. But we're going to stop here. We're only looking at 3/4. That's where we're going to stop. So how many groups of 1/4 are there? 1, 2, 3. So there are 3 groups of 1/4 in 3/4. I didn't keep jumping down my number line because I was only interested in 3/4. I didn't need the rest of that number line. We okay with that?
Where'd you get 1/4?
How many fourths? How many fourths? So fourth means 1/4. Good question. All right, let's keep going. Just rocking and rolling. We got good questions going on. So let's talk about that claim we made before about dividing the numerators. Example 2 was 9/12 divided by 3/4 equals 3. Exercise 1 was 3/12 divided by 1/4 equals 3. They both have the same quotient. Remember, quotient is the answer in division. So they both have the same quotient. I wonder how that happened. Well, let's take a look. Here we had 9/12. And, oops, I did this backwards. I'm sorry. When I put it back together from last period. These are the original equations. So 9/12 and 3/4. What do we know? Those are equal. Those were scaled down by dividing by 3. And what do we notice here about our divisors? Our divisors are also equal. They were both scaled down by 3. So if we scaled this down by 3, and we scaled our divisor down by 3, because they were both scaled down by the same amount, our quotient was the same. Exactly. So we can conclude that when the dividend is the big number in the house that's being divided. That's your dividend. That's your divisor. And your answer is your quotient. So when the dividend and the divisor are scaled up or scaled down by the same amounts, the quotient stays the same. All right, let's continue. So exercise number 2. 4/5 divided by 2/5. So let's find out how many 2/5 are in 4/5. That's what we want to find out. So we want to see how many are in 4/5. So draw your 4/5. And let's see how many groups of 2/5 we can find. Well, that's 2/5. And that's 2/5. And there's none left over. So how many whole groups was I able to make?
Probably
2. And that also helps us with our claim. 4 divided by 2 is 2 because we have common denominators. Try the next one.
Step 5 is 4 boxes.
We made 2 groups. Here's a group and here's a group because we want our groups to be 2/5.
Okay.
So this is 1/5 and 1/5. So that's 2/5. So that made a group. Okay?
On to the next one.
Well, let's look at the next one. Okay? 9/4 divided by 3/4. There's 2 different ways we could solve this one. One is like the number line that I told you. So go ahead and label your number line up to 9/4 because our first fraction is an improper fraction. How would we draw 9/4 using a tape diagram? Well, quite simply, God bless. So we could illustrate 9/4 on our tape diagram like this. This is 4/4, 8/4, and 9/4. So that's how we could illustrate 9/4 on a tape diagram. If you prefer to use the number line is also a model that you can use. It's your choice. So if we look at the number line, we're looking for groups of 3/4. So here's a group of 3/4. Here's a group of 3/4. And here's a group of 3/4. I'm stopping here because that's my 9/4. I don't care about 10/4 or 11/4. I was only looking at the group of 9/4. So how many groups did I make? 3. Oh, I forgot to write my sentence. Because you're going to have to do that on your homework. Now the model with the tape diagram will also work. Let's look at groups of 3/4. Here's 3/4. Here's 3/4. And there is 3/4. We also got 3 that way too. And again, our claim is true because 9 divided by 3 is 3. But still your homework is to show the models. Okay, but you could check it using our little numerator. Let's try another one. Oops, the answer's already there. 7/8 divided by 2/8. I guess I didn't erase this last period. So illustrate your 7/8. Okay. So the shaded in area represents my 7 out of 8. And I want to see how many groups of 2/8. So that's 2/8. That's a group of 2/8. And that's a group of 2/8. I can't keep circling because I don't have 2/8. So I made 3 whole groups. And how can I write that as a fraction? Exactly, very good. So 7/8 divided by 2/8 is 3 1/2. Don't we just love tape diagrams? We could totally see what this means. I understand what division of a fraction by a fraction is. Now let's take a look at number 5. We have another improper fraction. We have 13/10. So you have 2 options. We have our tape diagram. So I have 10/10 on my left and my extra 3/10 on my right. So I have 13 shaded in. If you prefer to do a number line, you should use a ruler. Let's see if I can get this to make a straight line. No, okay, doesn't matter. So 1/10. And you can continue your number line. But we're only looking at 13/10, so I know I have to stop it right here. So I'm looking for groups of 2/10. Okay? So let's see how many groups of 2/10. And again, you can use either model. That's up to you. So here, you could circle it like this. 2/10, 2/10, 2/10, 2/10, 2/10, 2/10. So let's see how many groups we made. 1, 2, 3, 4, 5, 6. We made 6 groups of 2. Okay? And then, if I made another group of 2, I have half of that group of 2 shaded in. Because I'm only looking at groups of 2. So I was able to make, if I make another group of 2, half of it is shaded in.
Wouldn't you do all the boxes left?
No, that's not 1 out of 7. Because I'm looking at groups of 2. So if I make this another group of 2, I only have half of this group of 2. Look, 1 out of 2. My groups are of 2, so my denominator is 2.
So like if it was 3, it's 3.
So, exactly. So if we were looking at groups of 3, well, then it would have worked.
Yeah.
Right, but okay. So here's a group of 2, and here's a group of 2. In that group of 2, only half of that group of 2 is shaded in.